So students, in this video I will go through exercise U4A07B, which is applying properties of sides, diagonals, and angles to identify kites or trapezoids on a coordinate grid. Let's take a look. So this is taken straight out of the Glencoe textbook from page 440 to 443. The question reads, quadrilateral ABCD has vertices given by those numbers there. Verify that ABCD is a trapezoid. So recall the trick that I showed you guys on a previous video, that whenever we're naming any kind of geometry, any kind of polygon, we're always going in either clockwise or counterclockwise rotation. So you can list it out as ABCD in this manner, or as ABCD. And it really doesn't matter, okay? And the reason why it doesn't matter is because by rotating it, by drawing the diagram in either orientation, it will both have the same final outcome of the diagonals, that both the diagonals will be AC and BD, no matter how you orient it. So just keep that in mind as we go through the exercises, because I will be applying that technique here. So verify that ABCD is a trapezoid. The best way to go about this is to find out whether or not we have at least one pair of sides that are parallel, and if we do, then that is by definition a trapezoid. We do not need to actually determine whether or not all four sides are parallel. If any two of them are will have the same slope, then they will be parallel. So I'm going to find the slope of, so I'm going to draw this. So this is A, B, C, D. I'm going to find the slope of AB first. The slope of AB is equal to 3 minus negative 1 all over negative 2 minus negative 4, which is equal to 4 over negative 6, and that is negative 2/3. I want to do the same thing with the slope of CD. Now, if the slope of CD is the same as slope of AB, then I'm pretty much done. The slope of CD, it will be 3 minus negative 1 over 3 minus 5. And this will be 4 over negative 2, and that is negative 2. So CD does not have the same slope of as AB. That's okay, because I need to see whether or not there's at least one pair of sides that have the same slope. So I'm going to find the other two pairs, which is the slope of AD and then the slope of BC. So the slope of AD will be negative 1 minus negative 1 all over negative 4 minus 5, and that will be 0. And let's see the slope of BC. The slope of BC is 3 minus 3 over 3 minus negative 2. And this also will be 0. So yes, this is in fact a trapezoid. So yes, ABCD is a trapezoid. Side AD and BC are parallel. Okay, then the second part here says determine whether ABCD is an isosceles trapezoid or not. So what I'm going to do is I'm going to, there are two ways that you can approach this. One way is to find the side length of AD and BC and see whether or not they are the same length. If they are, then that's isosceles. An alternate way is to find the diagonals to see whether or not they are the same. So I'm going to find the length of AD and BC. So the length of AD, I'm sorry, not AD, what am I saying? I want to find the length of AB and CD. So the length of AB is 3 minus negative 4. I'm sorry, 3 minus negative 1 squared plus negative 2 minus negative 4 squared. And what does that come out to? That comes out to 4 squared plus 2 squared. And that is 16 plus 4, so that's square root of 20. We're going to do the same thing. We're going to find the length of CD. The length of CD is 3 minus negative 1 squared plus 3 minus 5 squared. And that is 4 squared plus 2 squared. And again, that is square root of 20. So yes, ABCD is isosceles trapezoid. Okay, for each quadrilateral with the given vertices, verify that the quadrilateral is a trapezoid and determine whether the figure is an isosceles trapezoid. So what I'm going to do is pretty much apply the same technique. I will find the slopes of AB and then the slope of CD. So the slope of AB is equal to 1 minus 5 over negative 3 minus negative 2. And that is negative 4 over negative 1, which is positive 4. I'm going to find the slope of CD. 5 minus 1 over 3 minus 6, and that is negative 4 over negative 3, and that's the slope of 4/3. And then, so they are not parallel, so I want to try to find the other two slopes now, the other two sides. So slope of AD is 5 minus 5 over 3 minus negative 2, and that is 0. The slope of BC is 1 minus 1 over 6 minus negative 3, and that too is 0. So this shows that quadrilateral or ABCD is indeed a trapezoid. So what I'm going to do is I'm going to find the diagonals. And how do I find the diagonals? So remember, I want to find the length of, I want to find the length of AD, and that will be, if I'm finding the diagonals, it would be AC, so that would be 1 minus 5 squared, 6 minus negative 2 squared, and this would translate to square root of 4 squared plus 8 squared, so that's 64 plus 16. That would be 80, square root of 80. And if all goes well, BD, the other diagonal, should have the same exact length. So let's see. So 5 minus 1 squared plus 3 minus negative 3 squared. So this becomes square root of 4 squared plus 6 squared, and it looks like it's not an isosceles trapezoid. This is just a regular old trapezoid. So this is going to be square root of 36 plus 16. That would be square root of 52. So ABCD is a trapezoid only because diagonals AC and BD are not congruent. Okay, so the next part here, I have JKLM. So again, JKLM. So I'm going to find the slope of JK, and the slope of JK is 2 minus negative 6 over 6 minus negative 4. And that would be 8 over 10, and that is 4/5. The slope of ML, or LM, is equal to negative 1 minus 3 over negative 4 minus 1. And that is negative 4 over negative 5, and that's 4/5. Positive 4/5. Positive 4/5 and positive 4/5. This is indeed a trapezoid, because I have a pair of sides that are parallel. I want to now see whether or not it's an isosceles trapezoid. What I will do is I'm going to find whether or not JM and KL are the same length. JM, this time I'm finding the legs of the trapezoid and not finding the diagonals. So the length of JM is negative 4 minus negative 4 squared plus negative 1 minus negative 6 squared. And that is the square root of 0 squared plus 7 squared, no, plus 5 squared. And that's just 5. And I'm going to do the same thing with KL. So KL is 3 minus 2 squared plus 1 minus 6 squared. And that is the square root of 1 squared plus 5 squared. And that is going to be 26, square root of 26. So JKLM is not isosceles then. JKLM is not isosceles. So JKLM is just a trapezoid. But not isosceles. Okay? And we're going to repeat this idea again. I have QRST. So again, it really doesn't matter which way we draw it. So I have Q, R, S, and T. So we're going to find the slope of QR. And that will be 1 minus 5 over negative 2 minus 2. And that's negative 4 over negative 4. And that's positive 1. We're going to find the slope of ST. And that is 4 minus negative 6 over 9 minus negative 1. And that is 10 over 10, which is also 1. So yes, this is a trapezoid. We're going to now find the length of QT. So the length of QT is 9 minus 2 squared plus 4 minus 5 squared. And that is going to be 7 squared plus 1 squared. And that's square root of 50. And if it all goes well, then RS should have the same length as QT. So let's see if that's the case. RS, so it's negative 6 minus 1 squared plus negative 1 minus negative 2 squared. And what would that be? So that will be 7 squared plus 1 squared. And again, that is square root of 50. So this is indeed an isosceles trapezoid. So QRST is an isosceles trapezoid. Okay. Let's take a look at the next page. Very similar process, WXYZ. So W, X, Y, and Z. So I'm going to find the slope of WX. So if I do that, it's 2 minus negative 1 over negative 2 minus negative 5. and that will be 3 over 3, which is equal to 1. I'm going to find the slope of yz. The slope of yz is negative 3 minus 1, all over 5 minus 3. And that is negative 4 over 2, which is negative 2. So those two sides are not parallel. That doesn't mean that the other two sides are not. So I want to find the slope of xy. Slope of xy is 1 minus 2 over 3 minus negative 2. And that will be negative 1 over 5. Let's find the slope of wz. Slope of wz is equal to negative 3 minus negative 1, all over 5 minus negative 5. And that is equivalent to negative 2 over 10, which is equal to negative 1/5. So yes, we do have a pair of parallel sides. Now we got to find out whether or not it's isosceles. So to do that, I want to find the length of wx and the length of yz. The length of wx can be found by doing the following. Negative 2 minus negative 5. Whoops. Squared plus 2 minus negative 1 squared. And if we perform the computation, this becomes square root of 3 squared plus 3 squared. So that is actually equal to square root of 18. And if I apply the same idea, the distance formula with yz, so that will be 5 minus 3 squared plus negative 3 minus 1 squared. So that will be square root of 2 squared plus 4 squared. And 16 plus 4 is going to be 20. This is square root of 20. So unfortunately, this is not a isosceles trapezoid. So wxyz is not isosceles. Because wx is not the same as yz. Those are the two sides that are not parallel. Okay. Question 34. Refer to quadrilateral ABCD. Determine whether the figure is trapezoid. If so, is it isosceles? Explain. So it's basically the same question. Very, very, very similar. So because it's already drawn for us, I'm going to figure out the slopes by counting, and I'm going to figure out the lengths by using the Pythagorean theorem. So the slope of BC, if I look at this, I'm going down 3 and over 4, so this is negative 3/4. I'm going to find the slope of AD. The slope of AD, I go down 2, 4, 6, and then over 2, 4, 6, 8. So yes, it is negative 3/4. So yes, this is indeed a trapezoid. The two sides are parallel. And now I'm going to find out the side lengths of AB and CD. So AB will equal to, let's see here, 2, 4 over and 1 up. So that's square root of 17. Right? 4 squared plus 1, square root of 17. And then the length of CD is equal to 4, because I'm going from C to D, I'm going down 4, it's a length of 4. So this is not an isosceles, so ABCD is not isosceles. Because AB is not the same as CD. The slope BC is parallel to AD. is the midsegment contained in the line with equation y equal to negative x plus 1? Justify your answer. So let's see here. Negative x plus 1 is this guy right here. And clearly we can tell just by this that this is not going to be that is not going to be the midsegment, because the midsegment is supposed to be parallel to the bases, right? So no, midsegments must be parallel to bases. So the slope of AD is equal to negative 3/4. The slope of this line is m is equal to negative 1. So they're not the same. Okay, find the length of the midsegment. Okay, so to find the length of the midsegment, all we got to do is find the length of DC plus the length of, BC. Find the length of BC plus the length of AD and divide by 2. So the length of BC, remember I'm going down 3 and over 4, but the length of BC is going to be 5. And the length of AD is I'm going down 6 and over 8, so that's a length of 10. Pythagorean theorem, or not Pythagorean, 3, 4, 5 triangle. So the midsegment, therefore, is going to be 15 halves, or 7.5. Okay, determine whether each figure is a trapezoid, parallelogram, square, rhombus, or quadrilateral, given the coordinates of the vertices. Choose the most specific term and explain. Okay, so well, there's no other way of doing this but to find out some information about this, right? So I have A, B, C, D, right? So I'm going to determine whether or not the slopes are going to be the same. So let's do a slope of AB. Slope of AB is equal to 6 minus 4 all over 2 minus negative 1. And that is 2 over 3. I'm going to find the slope of CD. The slope of BC. And that will be 3 minus 6 all over 3 minus 2. And that is negative 3. And I'm going to find the slope of CD. And that is 1 minus 3 over 0 minus 3. And that will be negative 2 over negative 3, which is 2/3. And I'm going to find the slope of AD, which is 1 minus 4 over 0 minus negative 1, which is negative 3 over 2. So this, just by looking at this, the slopes, this is not anything. There are no sides that are parallel, and there are no, no sides are parallel, meaning this is not a parallelogram of any kind, and it's not a trapezoid because there are no sides parallel. Is this a kite, though? I'm going to do one more test, and that is I'm going to find the slopes of AC and BD. So I'm going to find the slope of the diagonal AC. Let's see here. The slope of AC, 3 minus 4 all over 3 minus negative 1. And that is negative 1 over 4. So that's negative 1/4. And I want to find the slope of BD. if the slopes are perpendicular, are negative reciprocal, then this could potentially be a kite. So I'm going to find out, because in a kite, none of the sides are parallel. So let's do BD, which is 1 minus 6, all over 0 minus 2. And this is going to be negative 5 halves. So no, it's not. So this is just a quadrilateral then. And we're going to do the same thing here. I have WXYZ. So WXYZ. So again, I want to find the slope of WX. That's 4 minus 4 over 3 minus negative 3, and that's 0. The slope of XY, and that will be 3 minus 4 over 5 minus 3, and that will be negative 1/2. The slope of YZ, and that will be 1 minus 3 over negative 5 minus 5 is negative 2 over negative 10, which is equal to 1/5. And then the slope of WZ is equal to 1 minus 4 over negative 5 minus 3, negative 3. So that's negative 3 over negative 2, and that's 3 over 2. So this is, again, a quadrilateral, not of any specific kind. Right. So this is, again, a quadrilateral. But just to be on the safe side, I'm going to test whether or not this is a kite. I'm going to find the slope of XZ and WY. So let's see here. XZ, what's the slope of XZ? That would be 1 minus 4 over negative 5 minus 3. And that would be negative 3 over negative 8, or 3/8. And I want to find the slope of WY, which is 3 minus 4 over 5 minus negative 3, which is negative 1 over 8. So the diagonals are not perpendicular. So yes, this is just a quadrilateral. Oops.